Okay, welcome to day 6 of Advent of Code. Um, Again, I started a little early because day 5 also didn't go particularly well, so I guess I should revisit that. Um, so the first thing that we went through, not that it actually cost me much time or anything, but um, so we used arrays of integers as coordinates. Arrays of integers always of length 2. Uh, and that's because tuples in Swift are not hashable. I mean, this still annoys me just because it's one thing for tuples to be a second class data structure, but Swift has these nice functions where you can actually name the fields in a tuple. And so it seems weird that you suddenly. Well, it just seems like there's an annoying discontinuity between tuples and real structs. And it is what it is. I don't know whether the core language group is working on making tuples conform to the various protocols, hashable, equality comparable, or whatever they call that, and regular comparable. But anyway, but it's worth remembering that tuples are second class, whether we like it or not. And that means, well, we can do this for homogeneous tuples, of all the same type, just use arrays instead. We couldn't have done this if we wanted to put two types together. We would have had to write a struct, which, I mean, isn't really a lot of work, but it's annoying that tuples and trivial structs are so different. Anyway, but parsing for day 5 only took about 5 minutes, which is good. So that's a positive. I had the question while I was programming what the return type of set insert was because I couldn't quite remember. Because where do we do? Because when we do this, we could have done this and used its return type in the if, because we were going to do this insert anyway, and that would have been slightly cleaner code. The return type of set insert is actually a tuple with named fields. It does return the bool to tell you whether it happened, and it also returns this element. And this is again a case of Swift actually being quite well thought through and forcing you to consider the nuances, because set, you will insert something if they compare equal, but just the fact that things compare equal doesn't mean that they are equivalent in all ways. So you might want to actually see what the element that's actually in there really is, if that makes any sense. Yeah. So if you're curious, go and read the documentation for what the member after insert means. I named my variables, starting at the top, SX and EX for start X and end X. And I'm quite a pedant for these things, and I'm amazed I let myself get away with it even at the time, because start pairs with finish, whereas begin pairs with end. And I mixed those two all over the place, and that's, and they do pair up. Okay, so now we're getting into, I actually did have the first part of day 5. Actually, I was very happy with how it went. I only placed 637th, but I guess that's about where I am right now if things go well, and I'm fine with that. But for the second part, I submitted a lot of wrong answers. And one thing is, several of those were just submitted because, my program spit out a number, let's just get it in there, because I was so sure, particularly after doing so well on part 1, that I was really close to finishing part 2, so why wait to think it through before plugging the answer in? And it turns out I was farther than I thought. So, after a couple of wrong attempts, you should probably slow down and recognize that you're probably not that close to the answer. Quite early on in this debugging process, the words I said, because I watched my little video, I did watch at double speed because I don't know who can watch these things at normal speed. They're incredibly dull. Um, but I said if you have 1, 1, and 3, 3, subtract them and get 2. And so the things are 0, 1, and 2. And that was my justification for for making this a dot dot less than range. But of course, that's the words I said were exactly wrong, because if you go 0 dot dot 2 is 0 dot dot less 2, what you get are 0 and 1, and you don't get 2 at the end. And that's exactly what the problem is. And as is so often the case, the fact that when I thought this through, I didn't think it was terribly important. And when I said this, I didn't think it was terribly important. So I didn't think very closely and realize that what I was saying was wrong. And then after the fact, I remembered having thought this through because I had said it. And so I assumed I didn't need to rethink it. And that's I don't really know how to take that lesson from that. Take any lesson from that, but it's something that sometimes happens. I built this nice little visualizer. It's only a few lines of code, and I didn't actually manage to get any benefit from it in this case. But I still think when there is a nice way to visualize your data, and it only takes a couple of minutes, if things are going badly, it's not a bad way to kind of force you to sit back and think things through. So I don't really mind that I built the visualizer. And in hindsight, I mean, there are a lot of things I did wrong in this debugging, but once I had the visualizer, I could have actually used, because, you select a character in BBEdit, and it tells you what line and character number it is, and those are the coordinates. So I could have used that to actually check, find some diagonal in this visualization and go and find it in the input and then kind of compare the two. That would have revealed the problem. Not the best way to reveal the problem, but that would have shown me what I was doing wrong. And I didn't do that just because I wasn't doing a very good job last night. I could have actually pulled out the code for the diagonals, which is just this little block here, and I could have just run it by hand on a couple of inputs and seen what it shoved into the has vent. Yes, just the has vent thing, really, or just logged, just printed these things as they came out. But I didn't do that either. If you were writing real production code, you would probably unit test little things like that, right? In fact, that would be the first test you write. If you were doing test-driven development, you would have, put in 1133, and checked that it hit those things before you even wrote this code. So, I'm very often disdainful of true engineering practice in the programming contest environment, but when things aren't going well, you should fall back on some reasonable practices. So I wouldn't say I had much of a good debugging strategy here. In fact, I knew that the bug was in these 5 lines of code, and yet it took me forever, 20 minutes or something like that, before I even tried hand simulating. And as soon as I hand simulated it across a sample input, it was obvious what I was doing wrong. And if you only have 5 lines of code, the first thing you do is hand simulate them. It's not. So I just don't know what I was thinking. How are we doing on time? We have a minute. I did 2 days ago. I uploaded it in 460p. Last night it is 720p, which is just good enough, but I still think I should go to 1080. Let's try and make tonight faster, so that's a smaller file size for the 1080p thing. I should also say, Advent of Code, usually it's when we're into our third week that I actually feel quite worn down by doing this every night. The main thing is it's at a poor time of day for me. I'm just not very sharp at the end of the day, and I find it very hard to get to sleep after I do these things. And it's definitely screwed up my sleep schedule because this afternoon I I passed out for 3 hours with no warning. So, anyway, let's see what day 6 has. Well, it's suggesting I actually use a timer instead of using math. Sometimes these problems you can do them manually for the first round, and the second one you've got to do some number theory. But yeah, for 80 days. 80 days is not a big number. So we'll do this first one by hand. We're not even going to parse this. We are just going to say, hey, I copied that, didn't I? Copy, paste. There we go. Okay. Well, we might want to log this. So there's already a weird off by one thing because I don't know would there be after 80 days. So I actually do want to execute this 80 times, not on the 80th day. Remember last time how I didn't get this right? Yeah. Okay. So what's the deal? Nude. Ooh, sexy. I felt uncomfortable. Well, no, let's do the easy cases first. Six, that's what he says, right? Because that represents the fish that already exists. And the new fish is on the day 1. We did that to 6, and a new with 8, right? Okay, and then you know what? Let's after each day do that. So come on, where's my, there we go. Oh no, what? Empty. Oh, of course. Sorry. Well, that's not unreasonable as a number, so let's see how it went. Okay. 460, so this is our best so far. Live forever. After 2 fixes. So this might not work for 256 because the numbers might get too big. Let's. Oh, sorry, I didn't mean to obscure my beautiful face. Let's just see. Ooh, it's getting quite slow. I haven't been printing T, so let's actually. Um, See, I don't know how close we are. Should we bother? Should we just let this run? Oh, okay. Do. Oh, sigh. I don't know if brute force is. Oh, what is AOC? I don't have access to that. Should I let this run? I don't know. No, I think it's getting particularly slow. So let's. Hold on. Okay, just so we have that. Oh, so we might have been getting moderately close. It's not ridiculously slow. Oh, you know what? And then we can. Oh, how do we? Oh, can we pass the -O flag to Swift? I don't know. That's definitely substantially faster, isn't it? So we might get to 256 before we come up with a faster way to do this. So what did we want to do? I wanted to capture this variable. Oh, just in case it comes up. Okay, so what are approaches to doing this more quickly? Because we have about 100 to go and they are getting substantially slower. Oh, of course, we could just count the number of. Oh, there's a much faster way to do this. We just need something that is a dictionary from ints to int. So the count of the number of fish at each stage. Right? Actually, before we do this, let's. We've lost this because I should have realized this immediately and programmed it right away, and it's easy. So equals oh my god, I'm such an idiot. We could have done this in a one-liner, but I couldn't remember the syntax. Okay. D. Right? Okay. What am I doing? 4. Oh, and how do you iterate over 4 n count in counts? What? Yes, so we subtract by 1, right? So new count minus 1 minus 1. No, plus equals. Right? Okay. Have we actually... Oh no, we ran out of memory. Okay. That's fair. So we have to do it the smart way. Oh, that didn't work. Oh, of course. So 10. Because when you look up, actually, how does that work? So let's just get this first line working before we try and edit other things, because I forget how any of this works. Yeah, so apparently that does work. I don't think you need it for that, but for this, you just have to assume, just to make sure it's there. And we are including 8 because it's 0.8. So we got that. Now what? That's, oh, this is the wrong output. What? Nope. Yeah, it's a number. It looks big. Big number seems appropriate here. And that's all you need is a big number. And I wasn't even in the top 1,000 on that one because, yeah, we should have gone for it right away. That's my fault. How did we end up doing? 13 minutes. See, look at that. Over 8 minutes between the first and the second. And that pushes just out of the top 1,000. I think we're resetting our goals that hitting the top 1,000 is pretty reasonable. In prior years, I was shooting for the top 100, but top 1,000 will do me. So anyway, that was a good day. I do like the ones where there's a brute force solution for the first half and a more clever solution for the second half. So I kind of enjoyed that, and maybe the fact that it was quick, I won't be quite so stressed, and I will come back a little more energized tomorrow. So see you then.